Today's lesson is the beginning of Unit 2, which will be solving algebraic expressions. Today's goals, students will be able to define a variable, constant, algebraic expression, and numerical expression. Students will be able to evaluate algebraic expressions or solve them by substituting the variable's value for the variable and then solving. We're going to get started with vocabulary today because that really is important to our lesson. So if you could take out your vocabulary goodbye list or whatever you're taking notes on, um, and just go ahead and pause this video, please, and write down the words, what chapter they're in, and the definitions. When you are ready for the examples, go ahead and unpause, and you will do that with me. All right, so you should be done writing down your words and definitions. So let's go ahead and go through it quickly and come up with an example for each one. Our first word is variable. A variable is a letter or symbol to represent a value that can change. So I might spend X number of dollars. Well, one day that might be $2, another day that might be $100. So the X of how much money I'm spending is going to change. So we use letters for variables. So for examples, X could be a variable, Y could be a variable, W could be a variable, Z. Any letter can be a variable because that represents something that can change. The next word is constant. That is a value or number that does not change in value ever. So the number 2 is always worth 2. The number 100 is always worth 100. 1,412 is always worth 1,412. So any number is what we call a constant. An algebraic expression is an expression that contains one or more variables. So remember, an expression is different than an equation because it doesn't have an equal sign. So we're not going to have equals something, we're just going to write an expression. So that might be 8x. You can see we think of variables when we think of algebra. So because it has a variable, that would be an algebraic expression. Another example would be 3x minus 2. That expression does not have an equal sign, so it is an expression, has a variable. We could also do, how about 5m divided by 3. That would be an expression, no equal sign, and includes a variable. Evaluate, just a reminder that evaluate just means to solve. So if a number asks, or if a problem asks you to evaluate the problem, they just want you to solve it. So if I asked you evaluate 2 plus 2 equals that equation, then you would go ahead and solve it and say 4, and you could draw an arrow to that. So if, again, my directions are to evaluate, then you're going to tell me 4. It just means to solve the problem. And this is also a review from chapter 1, if you don't already have this word, numerical expression, a mathematical sentence with only numbers and operations. But remember, because it is an expression, no equal sign. So 2 plus 2 is a numerical expression. You can see there are no variables. 4 times 80 is a numerical expression, no equal sign, and no variables. All right, let's go ahead and do an activity to practice that. What I would like you to do on your paper, if you already have these headings, is just go through these one by one, cross them out, and put them in the correct spot. If you don't have the headings, then go ahead and pause and do the same thing. So you are going to sort all of these expressions and variables and constants into the correct category. So please pause the video, go ahead and do that, and then you can unpause to check your answers. All right, so now that you've had a chance to think about it, I'm going to go through. I'm going to start with x. That is a variable. It is a letter. The next one, x plus 2. That is an expression, no equal sign, and it does have variables, so that's an algebraic expression. This is also an algebraic expression, no equal sign, and it does have variables. This is a letter, so that is a variable. 8 is a constant, a value that doesn't change. M is a variable. 2 plus 3 is a numerical expression, no equal sign, but it's just numbers, there aren't any variables. 3x plus 4 is an algebraic expression. 1 plus 2 equals 3. Now this is not just a variable, it's not just a constant, and it's not an expression because there is an equal sign. So we're going to put this in the none of these category. P plus 2p is an algebraic expression. S is a variable. Z is a variable. P is a variable. 144 is a constant. 4 is a constant. 6 plus s is algebraic expression because it does have a variable. 10 minus 1 is a numerical expression, only numbers and operations. 8x is, remember, is the same as 8 times x. That is an algebraic expression. This one also has an equal sign. So this is going to be an equation, which we'll learn more about later. So that will be none of these. 12 is a constant, and 10 is a constant. Go ahead and fix any problems that you got wrong. You can pause the video if you need to before we continue. All right, so we're going to make a T-chart for our notes today, and we're going to learn how to evaluate expressions. And the way that I like to remember it is substitute and solve. So here we have an expression, s to the second power minus 15 if s equals 5. So they're going to tell you what the variable equals. Your job is going to be to figure out what will that expression equal if s is equal to 5. So again, right here we have our question, what does the algebraic expression equal? So our next step is we're going to look at what the variable equals. It says s is equal to 5. So wherever I see an s in the expression, it really means that I have 5. So now what we're going to do is I'm going to write out the problem, s to the second power minus 15. Right underneath it, I am going to rewrite the problem and I'm going to substitute 5 for s. So wherever there's an s, I'm just going to write a 5 instead, and I'm going to copy everything else down exactly. Now, you might feel like this is a little bit of extra work, but it's going to get you the best results. So instead of s, I wrote a 5 because s is equal to 5. Then I copied it's to the second power. I copied my subtraction sign, and I copied the 15. Now I have an expression that I recognize and something that I can solve using order of operations. So first I'll do exponents. 5 to the second power equals 25 minus 15. And then I'm ready to solve, and I can see that that is equal to 10. All right. So just a reminder here that when you see a number and a letter next to each other, it means that you want to multiply. So 7x is 7 times x. So go ahead and try this problem. 8 divided by x is the same as 8 over x is the same as 8 divided by x. So if I told you that x was equal to 4, you could then solve this algebraic expression. You would rewrite this and say 8, instead of divided by x, it's going to be 8 divided by 4, which should be equal to 2. All right, so that's going to conclude our notes. Let's go ahead and get some practice here. All right, so here's an activity to practice this. It says evaluate the expression. So what I'm going to do here is I'm going to roll the dice for our value of x, and then you can go ahead and pause and see if you can solve it. So let's do the first one together. We're going to solve 3x plus 2 if x is equal to 5. So again, first step is to make sure that this problem is written down. Then we're just going to copy the problem. Instead of x, I'm going to put a 5 because when I rolled it, x is now equal to 5. I'm going to put the 5 in parentheses. When you see a 3 next to the x, it means times. When you see 3 next to a number in parentheses, it also means you're going to multiply. And then we'll copy the rest of it, plus 2. We always use order of operations in everything we do, so we'll multiply first. End up with 15 plus 2 equals 17. So let's do another one. You can try this one by yourself. Pause the video if you need to. Go ahead and solve if x now is equal to 3. All right, so I'm going to go ahead and do that. 3 times 3 instead of x, because x equals 3, plus 2. 3 times 3 is 9, plus 2 is equal to 11. Oops. We'll erase that. And one more time. How about if x is equal to 6? Give that a try. So we're going to do 3 times 6 plus 2. 3 times 6 equals 18. Plus 2 is equal to 20. All right. Let's move on and try a little bit more challenging one here. All right, so now we're going to evaluate this expression, and that is 10 plus x to the second power in parentheses minus 5. So again, we're going to roll the dice. And how about if x is equal to 5? So again, I need to rewrite this problem. 10 plus, everything's going to stay exactly the same, except when I get to this x, I'm going to put a 5 instead of the x. Now I can go ahead and solve using order of operations. Exponents is first. 5 to the second power is 25. So 10 plus 25 in parentheses minus 5. We'll solve the parentheses next. Get 35 minus 5, which is going to be equal to 30. All right, let's try one more. How about if x is equal to 4? Go ahead and try that, pause, and then find out if you are correct. All right, let's copy this problem exactly. 10 plus x. So instead of x is equal to 4. 4 to the second power, parenthesis minus 5. Solve your exponents first is 16. So we're going to do 10 plus 16 minus 5. Next we'll solve our parentheses, 26 minus 5, which is going to be equal to 21. All right, I have a slightly different challenge for you. I'd like you to try to figure out what number for y would make this equation true. So you can either just go ahead and try. You can roll a dice and substitute and solve and just see if it works. Or go ahead and just try 1, 2, 3, 4, 5, 6. Just do a little guess and check and modify your answer as you go. I'll do this first one with you. I'm just going to try something. I'm going to try a 2 and see what happens. Well, 2 times 2, that's going to be equal to 4. Plus y again, so plus 2, that equals 6. So that is clearly not large enough. So y is going to need to be something that's going to be bigger than 2. I'm going to try 4. How about if y is 4? So I'll rewrite the problem. 2 times 4 plus 4. 2 times 4 is 8, and 8 plus 4, sure enough, does equal 12. So this would be my answer. In this problem, y is going to be equal to 4. All right, why don't you try one more on your own? Again, just go ahead and guess and check. Pick a number between 1 and 6, substitute and solve, give it a try. If it's too big, try a smaller value for y. If it's too large, then you want a smaller value for y. If the number is too small, you want a larger one. So go ahead and pause and give this one a try. All right, if you got y equals 6, you are correct. You can see that when I substitute and solve, 2 times 6 is 12, and 20 minus 12 is 8. All right, just one more set of practice problems. I'd like you to give these a try, pause the video, and then go ahead and check your answers. All right, so here's the answers. Go ahead and take a moment to check them. If you did get any of the problems wrong, I really want you to look at how I showed my work and fix it and do it with me. So this concludes this lesson. Good luck on the practice and checkpoint on your own.